All right, super happy to have you. Thanks for joining us again, guys.
Thanks for having us.
My pleasure.
So the first thing I'm going to ask you to share with our audience is sort of a quick assessment of the big picture. So you did this back in March. Things have changed. Can you kind of give us a quick statement of where we are now in the pandemic, both in the US and globally?
Yeah, I think I can start off. I think we've made progress since we last talked. The number of people vaccinated has increased substantially, which is good. But we've kind of plateaued and hit the vaccine hesitant group. Obviously, we've had new variants, alpha, beta, gamma, and now delta. Cases are on the rise. So I think right now is not a great time in the country, as we're seeing hospitalizations, case numbers, deaths increasing, particularly in southern parts of the US. Globally, still much of the world that hasn't received any vaccine. And so it's one issue when we're talking about third injections and boosters, and whether we should get third injections when most of the world hasn't had a single one. So I think it's a bit of a mixed bag, but we clearly do have very good, safe, effective vaccines, and we just need more people to take them.
Bill, you want to add anything to that?
Yeah, I want to concur with that statement. I also want to mention on an optimistic note that the vaccine wall is still holding. Vaccines protect against death and severe disease, even with Delta. That's going to come up, I suspect, as a question. That's a very important thing. In terms of vaccinating the world, there is a number of vaccines in the pipeline for the developing world that are much more affordable. There's also scaling up of capacity for current vaccines and distribution around the world. Those vaccines are going to get out there probably in 2022. But it is true that, for example, in Africa, vaccination rates are below 1% across most of the countries there, and frontline medical workers still haven't had their first shot. Think about that as you refuse, or you listen to people refusing their free, readily available shots here. So that's discouraging. In addition, I'd like to add that we now have a number of therapies, if administered very early. These are typically monoclonal antibody therapies. They work, again, in certain cohorts when administered early. And there's still quite a lot of work on small molecule inhibitors for SARS-CoV-2 as well.
All right, I'm going to go through a set of questions now, and you've seen most of these. Many of these are related to things that I hear about people's hesitancy or their misconceptions or misinformation. And we build this event as having two molecular biologists give you the science, the data, and the facts, instead of hearing it from a politician or a TV celebrity or a host or a crazy neighbor who suddenly thinks they're a virologist or epidemiologist. So I'm going to ask you questions, though, start at the beginning, that start from the most basic ones we hear out in the community, so you can correct those misconceptions. And then we'll get into some more of the scientific aspects of this and where we're headed. So let me start with the softball. Remind everybody how this is different than the flu. I actually got in an argument with somebody about this last week. I thought 18 months later, we were beyond that. No, this person thought this was just like the flu. So can you remind the audience and share with them how they can explain to people how this is different than the flu?
Sure. Ilya, why don't you take this one?
Right. Well, with the flu, I guess, first of all, just to distinguish the signs of the flu from flu-like symptoms, remember, lots of respiratory viruses can lead to flu-like symptoms with different outcomes. But the flu itself is quite a bad disease, causing lots of death around the world, right? And hospitals are frequently overwhelmed during flu season, and they have to beef up capacity. Having said that, our immune systems are not naive to the flu and flu-like viruses. With SARS-CoV-2, that, at least 18 months ago, was not the case. It was truly a naive infection, and our immune systems didn't know how to deal with it. For those people who haven't had a vaccine or have not had a prior SARS-CoV-2 infection, their immune systems are still naive. For those who are immunocompromised, vaccine may not have taken, their immune systems are still naive. And therefore, SARS-CoV-2 can get in there and wreak havoc quickly before our immune systems can catch up. This leads to increased mortality. The transmission profiles are also different. The fact that many people are asymptomatic and can still disperse the virus widely is also a big problem. So these are just some of the major differences between this and the flu.
Yeah. And to sum up, I think it's more infectious than the flu, particularly the Delta variant, where we're looking at this R naught value, which is roughly the number of people that get infected from one infected person. So originally, the Wuhan or Washington isolate was maybe three to four. The Delta variant's maybe 6 to 8. It's hard to calculate the number exactly, but that's substantially higher than seasonal flu. And then also the hospitalization or case fatality rates also higher, particularly with the Delta variant. Flu does normally cause a severe burden in the very young. We don't see that with SARS-CoV-2, so that is a difference where SARS-CoV-2 is really attacking the elderly, but we are starting to see more pediatric hospitalizations now with the Delta variant, which is concerning.
So just to summarize that, it's more contagious. There are a higher probability of serious outcomes. Those serious outcomes affect an older population instead of a younger population. So it's still a virus. It's both do bad things, but it's more infectious and a higher probability of a bad outcome.
Yeah. The mortality curve for flu is almost always U-shaped, where it's worse at the very young and the very old, the elderly, whereas this seems to be mostly towards the elderly.
Great. All right. So talk about how much more contagious Delta is than the original variant. And Jason, you hit on it, and I just listened to an NPR podcast that gave those same kinds of numbers about original variant, sort of an R naught of 2, and this one is in the 6, 7, or 8 range, still slightly less than chickenpox, but pretty darn, the R naught's very high. Can you talk about the degree of how much more contagious it is and why that's bad, even though half people have been vaccinated now in the presence of Delta?
Yeah, so clearly we saw that with an R naught of 2, that was sufficient to start a global pandemic. And so if you're going up 2 to 3 times in terms of infectiousness, that's obviously much worse. And then there's also things like the replication kinetics seem faster, where it's able to cause disease within 4 days compared to 7 or 8 days, which gives the immune system less chance to respond, which is why having pre-existing immunity from a vaccine can be really helpful.
And I should mention, for those who may not be following this as closely as Jason and I do, R naught really has an intuitive explanation. This is just the number of people that somebody who's infected with the virus can infect on average. So somebody who's infected can infect on average 3 other people as an R naught of 3. That's a rough way to think about it. So Delta has become significantly more infectious than the parental strains that were circulating before it. This is not the first time this has happened. We have seen increased infectivity in other strains. The UK variant, before that, this variant called D614G. One other problem with Delta is the number of viral particles that are emitted seems to be larger. So the viral load upon infection can be higher because people are just spewing it out more. And this ties into this larger R naught. So more particles means less time for immune system, means more severe outcomes.
Are we seeing a higher mortality rate with this variant than the original variants?
You know, I want to be careful here. I think the science is still unsettled on this. Remember, we're watching the science happen in real time, and people have to understand that it takes a lot of data and a lot of studies to really get at that. Jason, do you have a better answer? I guess the UK has been the most careful in monitoring this.
Yeah, I haven't seen data suggesting that maybe the case fatality rate is higher. I mean, anecdotally,
but that's tricky because that's tied into the hospitalization load. And you know, if you have, like in Austin, we have very few ICU beds, the fatality rates will go up because care degrades.
Yeah.
Right.
Yeah, so that is a value that fluctuates, particularly as we have to start triaging patients and other things. It does seem like the patients deteriorate more quickly. Younger people are going in, but I haven't seen any good estimates on whether the case fatality rate is substantially different.
Yeah, that matches my view. If it was substantially different, I think they would have picked it up by now. But it probably won't be substantially different is my guess. Or if it is, it's just a little bit worse.
It's stuff that, I mean, it could double, right? But still only go from 0.1% to 0.2%. So right. I don't think it's gone up in order of magnitude.
Got it.
Right.
Would it be classified as more deadly based on its R naught if it had the same mortality percentage, but 2 to 3 times more infectious? How do epidemiologists characterize something like that as same mortality rate, but more deadly because it's more infectious? Or how do you distinguish between how many people you're infecting and what the mortality rate per person is?
Oh, well, that's exactly why we have those two different stats, right? R naught is solely about the spread in infectiousness, and case fatality rate is the number of deaths per case that's confirmed. So there can be differences. The actual mortality rate can be different because we're looking at the number of cases where you've tested positive. And that depends on how often and how frequently you're testing, but we do separate those two.
Yeah, you have to think about it from an individual versus a community perspective. Yes, at a community perspective, if you have a more transmissible variant, it will cause more deaths, but it may have a lower individual fatality rate, but it gets more people exposed. You know, for personally, I would imagine that a virus that is hard to transmit but is super lethal would not produce an epidemic, whereas a virus that is easy to transmit but maybe less lethal can produce an epidemic, right? So transmission is actually more scary than, you know, the individual fatality rate from a pandemic population perspective.
And I think that's what I was trying to get at. I want to make sure our listeners understand that even if the mortality rate on a per capita basis is roughly the same, the fact that it might affect people 3 times faster or 3 times as many people is a cause for potentially an increase in number of fatalities. Is that fair?
Yes, I think that's fair.
Okay, so let's talk a little bit about, of course, fighting against that is the fact that roughly half the people in the United States have been vaccinated now. So it may be 2 to 3 times more infectious, but we know the vaccines are holding up pretty well against serious illness and death. So that works in the opposite direction, which is great. And we're going to get to that. Talk a little bit about how the vaccines work. And we've all heard about mRNA vaccines, and we've heard about the traditional vaccines like the Johnson & Johnson, I believe. So can you talk a little bit about traditional vaccines? And, you know, I know Jason can talk about the mRNA vaccines and how they work.
Yeah. So the J&J vaccine is not a traditional vaccine. Actually, yeah, we don't have only Novavax, which is still not has received emergency use authorization, would be considered a more classical vaccine. So in that case, you are expressing one or more of the viral proteins. In this case, for Novavax, it's just the spike protein. They're expressing it in insect cells and huge 100-liter plus bioreactors, purifying that protein, mixing it with another compound called an adjuvant that helps stimulate our immune systems, and then just injecting it into the shoulder. And our body doesn't have to do anything other than recognize the spike as foreign and start mounting antibodies, B cells, and T cells. So that's a fairly classic vaccine that that we've used. All the other vaccines are actually fairly, let's see, they're new in the sense that this is many times the first time that they've been employed on a large scale, but they've been in development for maybe 1 to 2 decades. And so for both the Johnson & Johnson vaccine, which uses an adenovirus, and the mRNA vaccines, there you are putting the gene for the spike protein in either the adenovirus backbone or in the mRNA. And then you're injecting that. And then the genetic information goes into the muscle cells, just locally, regionally, it's not going throughout our bloodstream. And then the muscle cells make the spike protein and display it on the surface of their cells. And then our body recognizes it as foreign. And so it's really fast. That's why those are some of the first ones out, because you can just synthesize mRNA in a lab. Whereas if you're trying to make the actual spike protein, you have to first make a stable cell line, then work out all the purification conditions, and then the protein has to be stable in the vial. And you're seeing that, you know, Novavax is, you know, it's pretty late to the party.
So
I should mention, you asked about traditional vaccines. Actually, there are traditional vaccines, what we consider traditional vaccines, out in the world, mostly out of China. These tend to be inactivated virus or attenuated virus vaccines.
Right.
And those actually they take a long time to develop, just like the subunit vaccines, like Novavax. And they actually haven't performed nearly as well as the RNA vaccines.
Yep. And there's reasons for that. I don't think many of them are attenuated. That's a very tricky one where you're trying to weaken the virus, but still allow it to replicate in a person. And so you usually need some genetic trickery. And then if you attenuate it too much, it doesn't elicit a good immune response. And if you don't attenuate it enough, you're injecting like virulent virus. And so I think like some of the ones from China and others, those are just inactivated. Grow up a lot of virus, treat it with a chemical, inactivate it. But that deforms the proteins on the surface, and it no longer makes them look like how they are on the live infectious virus. And that's one reason why they haven't performed as well.
So Jason, you hit on a couple of things there. You said there's a couple that use mRNA, and you said the J&J one uses an adenovirus.
J&J uses adenovirus,
Okay.
as does the AstraZeneca that uses like a chimpanzee adenovirus, whereas J&J uses adenovirus 26.
All right. So quick, easy question. Do any of these vaccines give you a chance of getting coronavirus?
No, it's none of those
Right.
are it's even possible.
I was going to put a whole section of myth questions in here, but I decided instead I'm going to sprinkle them throughout. I'll probably save the 5G question for the end for fun. But so this has been one of the bits of misinformation that I noticed that I've been dealing with as I come across people in daily life. They're worried, can I get it from this? And I've said, no, it's not from the three that you're likely to get here in Austin anyway, not from any, I assume. The attenuated one, does attenuated virus vaccines, do they present any not that we have one for this, but do they present any possibility of catching it?
Yeah,
whatever
exactly. Yeah, one of the polio vaccines that's a live attenuated one, that one, if it's not properly attenuated or it goes into an immunocompromised person, or potentially if it reverts back from the attenuated form to the wild type form, then that can cause problems.
And to be clear, none of the COVID vaccines use an attenuated form of the virus.
That's correct.
Great. All right. So can you say just a little bit, Jason, about how the mRNA vaccines work? Because that's what we're reading a lot about.
Yeah, let's see. In our cells, the flow of information generally goes from DNA to RNA to proteins. DNA is stable. It's inside of our nucleus. We have RNA polymerases that transcribe or convert the DNA gene into an mRNA, a messenger RNA, that then leaves the nucleus. It gets bound by ribosomes. The ribosomes then read along the mRNA and convert that code into a protein. And then the protein is translated and can be either inside the cell or displayed on the surface of the cell. And so what we're doing with the mRNA is that you've already encoded the sequence that you need to encode for the spike protein. It's encased in a lipid nanoparticle. The lipid nanoparticle helps the mRNA get through some of our body's defenses against RNA. The mRNA goes inside of the cytoplasm, doesn't go into the nucleus where our DNA and our genes are. It just binds ribosomes. The ribosomes translate it into spike protein. The spike protein is then displayed on the surface of our cells. So our cells have a bunch of little spikes sticking up. Our immune system recognizes that as foreign, starts making antibodies, T cells against it. The cells that are producing the spike proteins are probably destroyed. The mRNA gets degraded probably within hours, maybe no more than a day. The spike proteins get degraded as well. And there's really not much that lasts from these vaccines.
So one of the questions, of course, I'm sure you guys have heard it a lot, is how safe are the vaccines? What are not just the side effects from the day after you get the shot, but what are the potential negative impacts to your health from these vaccines, if any?
In general, there's really no such thing as long-term vaccine side effects. That doesn't exist. There are side effects from vaccines, and we've been using vaccines for over 100 years, and almost all the side effects from vaccines occur within about 2 months. And so we've now had people vaccinated for over a year, more than, dating back to March of last year. And so we're really not seeing very substantial side effects, except for this blood clotting issue that has been observed in like 1 in a million, or I guess there's 1 in a million deaths due to the blood clotting from the J&J and AstraZeneca adenovirus. For the mRNA vaccines, they have a really good safety profile and isn't too dissimilar from many of the side effects you see with other vaccines or drugs people take.
I just want to add a little bit to this. You all should realize that vaccines are probably the safest, most effective medical intervention known to man. It's probably the best way to describe it. And these mRNA vaccines are proving to be the safest of the vaccines out there put all together. So these are the safest of medical interventions known to man. I'm
really glad that you emphasized that. I've been trying to share as a non-biologist that the data shows that they're incredibly safe. And I like what you just said, that vaccines are among the safest medical interventions, and that these COVID vaccines are among the safest vaccines. And the other, of course, brag point is how effective they are. I think we all remember early in the pandemic when Fauci said he was really hoping to get some vaccines that were 60, 70% effective about this. Can you tell us how effective these vaccines have proven to be?
The effectiveness varies. So it's a little tricky, right? Because you're comparing it to a certain population at a certain time. And so the Moderna and Pfizer BioNTech vaccines, those were tested last year when most of the variants weren't around. And so that was against sort of the wild type version of SARS-CoV-2. And you were comparing it in general to a completely naive individual. And it was around 95% effective against symptomatic infections. And so that was really quite good. And then even better, essentially 100% effective against severe disease and death. But the landscape has changed in the fact that humans have changed, right? So people have been infected. The virus has changed. We now have these different variants, and we're starting to see some of the efficacy decrease, particularly against infection. That's not too unexpected. The vaccines weren't necessarily trying to prevent all infections. The goal is to prevent severe disease and death. So some of the numbers that are starting to come out now against the Delta variant is maybe Pfizer's only around 50% effective against infections, whereas Moderna's 80, 85% effective against infections. They're both higher. They're both more efficacious against hospitalizations and severe disease.
And I should add, you mentioned this, but I just want to repeat this point because it's important. Part of the reduction in efficacy comes from the fact that the virus has changed, but part of the reduction in efficacy comes from the fact that many more of the unvaccinated people have already had COVID. And so they are protected by having survived a COVID infection. Therefore, efficacy will appear to go down because the population has changed. So it doesn't all mean that Delta is completely, busting through the vaccine wall. This is a key point.
So last year, unvaccinated probably also meant uninfected, where now likely some fraction of unvaccinated are infected. And so you're comparing a vaccinated immune response versus a prior infection immune response. And so it's a little bit different.
Oh, right. So I get what you're saying.
Yeah,
now
so the corollary, the corollary is you cannot compare numbers across time. So if the Moderna number, Moderna and Pfizer had a really rapid, phase 3 and trial, and they could get their numbers out quickly. And that was a really good business decision because they got that 95% stamped on them. But of course, anyone who has to go through, these efficacy trials now will be in a completely different landscape. And those numbers cannot be compared across time because the populations are completely different, both viral and human. And the human unvaccinated population has got some immunity already as well. That's the key point. Can't compare these numbers. Sorry, that was an easy question, hard answer.
No, that's okay. And, one of the stats that I saw recently, and I'd like to ask you as the experts to make sure that, I'm repeating it correctly when I talk to my friends, that people on this call are repeating it correctly. But I was talking to someone and she was thinking that maybe it's not very effective. And I said, well, right now, about half the US has been vaccinated and about half hasn't. And if it wasn't effective at all, then you might anticipate that about half the people in the hospital were vaccinated and half weren't. And it was more like 97, 98% in the hospital were unvaccinated and only about 2% were vaccinated. So from that, even in this time, it appears that the vaccines are holding up incredibly well against serious illness. Is that right?
That is correct.
Yeah, they're holding up well. It's not as high as it used to be, but the numbers are really good looking at hospitalization rate per 100,000 vaccinated or unvaccinated people. You might see 75 times higher rate of hospitalization for unvaccinated people. The numbers changing a little bit, but it's really substantially helpful in preventing the hospitalization and disease.
Well, there's 3 questions that I want to ask you next, and I'm going to let you take them in whatever order you want. One is, do we have an estimate yet for the rate of decay of the effectiveness, such that we're starting to get a handle on when those boosters might be needed. Another one is, when do we think that the tests will be sufficient that kids 12 and under, or under 12, will be able to get vaccines? So let's start with those two.
Okay. Yeah, there's been some really good modeling studies. There's one published in Science looking at the waning of immunity. That was suggesting, I think after 250 days post-vaccination, the efficacy against symptomatic infections would drop from 95% to 70% for the 2 mRNA vaccines. But with J&J, where you're starting at 70%, after 250 days, you're actually down closer to like 30% efficacy. And then that actually, I think, was before Delta was published. So then those numbers get a little more skewed even with Delta. So I think if, let's see, for J&J, I think people should get boosted with an mRNA vaccine. And the numbers don't look particularly good for J&J against the Delta variant, even against hospitalizations and death.
Oh, okay.
Yeah. In some ways it's half a vaccine. Like the number for the 1 dose of J&J is really similar to what people have estimated for 1 dose of AstraZeneca or 1 dose of Pfizer. So I would recommend getting a boost of mRNA. And then when do people get 3rd injections? I think the
We're
data
gonna find
warrant.
out soon.
Yeah,
I mean, Israel's boosted 500,000 people, 600,000 people right now, 60 and older.
60 and older. Yeah.
Yeah. So Germany's boosting, United Arab Emirates is boosting, 3rd boost. I mean, so just wait a month and you'll get the data out of Israel. Right? They haven't seen the effect yet, but they'll know in about a month.
But I would just say it is tricky. I mean, I think the science would suggest that the 3rd dose would be really helpful. But then there's the inequity of us getting 3rd doses and the rest of the world.
I'm going to avoid the obvious policy issue on that inequity, because I'm asking you guys here as scientists, and I don't want you to feel that you have to weigh in on global politics and global equity issues of the vaccine. I know you both wish everybody could get 2 shots ASAP and we could get through this. And so I know that's what you want. So we're not going to go into the global politics, but although I'll say that just personally, I'm very proud that the US is beginning to export vaccines to other places and treating it, our leadership position in this as something to export. So I do want to ask about the kids, though. There's a lot in the news.
Before we go to the kids, you said I shouldn't let Jason be modest. He is also working on the global inequity challenge as well. And some of the things he designed are actually cost-effective vaccines that are hopefully going to get through phase 1 trials in multiple countries around the world.
Yeah, for one of the vaccines we've been working with a group at Mount Sinai, and Ilya's group was involved in this. We created a vaccine that can be grown in chicken eggs, which is very similar to how a lot of the world grows their yearly influenza vaccines. And so Vietnam, Thailand, Brazil, Mexico, and some others have been looking at this. And Vietnam and Thailand started in March, and we're actually right now writing up the results of the phase 1. It looks good. I can't give the actual numbers, but if it goes all the way through phase 2 and phase 3, it could allow these countries to make 25 to 30 million doses themselves in country without relying on any additional manufacturers. And so that would be really exciting.
That is great. And now that I see kids in the background in Ilya's screen, let's get to the question of when those little tykes are going to be able to get vaccinated. How are we progressing on that?
I think the data still suggests sometime in winter.
Yeah, I think winter is realistic. Although, did you see that recent? So we don't have any information that you can't read from CNN, but I believe the American Pediatric Association is trying to lean on the FDA to expedite it, which is the first time ever that the Pediatric Association asked for less data to expedite a medical intervention for children.
Yeah, but
first
looking
time in their history.
Yeah, I mean, you can get some insights looking at quarterly earning reports and things from Pfizer's, because it kind of shows their plan. It was supposed to be September. It looks like it's getting pushed back late November, and they'll just see when the numbers. I actually know some people who are rolling their kids and are getting injected next week.
All right, let's get back to some more of the science here for a little bit in terms of the vaccines and variants. Are the pharmaceutical companies tuning versions of the vaccines specifically for Delta and other emerging variants? And what do you think the time scale is? Are they already in tests on that? What do you think the time scale is for improved versions of these vaccines that are optimized for Delta variant?
Yeah, those are ongoing and are relatively trivial. Moderna has already tested a phase 1 comparing a third dose of mRNA 1273 to I guess, a first injection, but third shot of an mRNA encoding for the variant originally identified in South Africa, the beta variant. And that actually looked really quite good, but it also showed that just a third dose of the same vaccine worked really well against the variant. The mRNA companies, they within 100 days could be manufacturing mRNA vaccines against the different variants. But there's a lot that goes into it, and potentially within 100 days, you're already on to the next variant. And then there's other things about FDA. Would they have to do a phase 1 or phase 1/2? How much additional data would they have to do? But it's from a manufacturing standpoint, it's trivial because it's just RNA. It's just a few different nucleotides. It's much harder for the Novavaxes that are making a protein subunit, because that has to make an entire new stable cell line, potentially new purification procedures. The yields could be higher or lower. And so it's a lot harder for the subunit based vaccines.
And I should, thanks, Jason, that's really great, clarifies things, but I should maybe delineate a little bit here between what kind of third shot we're gonna want, right? Because a variant that spreads more quickly will, of course, but can still be neutralized with the original shot, should be boosted with the original shot. But a variant that starts evading the immune system should not be potentially boosted with their original booster, right? And so this is what Jason is referring to, keeping up with the virus and trying to predict where the viral evolution is going. It would be potentially deleterious to boost with the third shot from the original strain if you've already if the virus has completely evaded those antibodies, which is unlikely to happen, but you never know, biology is a strange thing. So we have to watch these breakthrough cases carefully and understand what the immune profile looks like and what these variants are actually doing to the immune system. Is it just overpowering it by sheer number, or has the virus learned tricks to evade partially our immune system? That could change the nature of the booster, which is really important. So rushing a third shot may not be the best strategy, is what I'm trying to say.
But the Delta variant actually doesn't contain very many antibody escape substitutions.
That's what I'm saying.
Yeah, it's far fewer. The South African one, B1351, the beta variant, that was much more concerning. It has a lot of changes that substantially escape our immune response. Delta doesn't. It's actually, it doesn't have too many changes. It's doing it with different replication kinetics and other things.
Right.
Well, Jason, that begs the following question, which is, should we be concerned of the emergence of the beta variant at scale?
It lost Delta 1, right? I mean, the viruses are competing, the strains are competing against each other to replicate quickly. At least for now, the pressure on the virus is to replicate more quickly through unvaccinated people. So beta had its chance, and beta is no longer, I mean, we track the distribution of, say, viral variants in Texas in collaboration with some folks in Houston, and Delta is 99-point-something% of cases right now. Beta has competed deep into the background.
You'd be much more concerned about Delta picking up one or two of the additional
That's
changes
the fear,
found.
Right? The Delta and beta. Yeah. So this is the concern, that Delta will learn some tricks as it tries to colonize our immunized bodies.
Yeah, and as it's replicating in either previously infected or vaccinated people, it's replicating in the presence of an antibody response, which allows it to select for progeny that have mutations that can grow well in the presence of antibodies.
Yeah, so this is what I'm kind of worried about. I didn't know that we're going to go there, but let's do it. Now there's plenty of evidence that the viral load can be pretty high in the noses and upper respiratory systems of people who are vaccinated.
Possibly.
Okay, we can agree that it.
That's okay. We can have scientific disagreement here.
At least
scientifically informed.
At least the qPCR values indicate that there is viral RNA, whether it's replicable or not.
But that can be wildly off from infectious units.
That's true. People haven't subcultured it. So we agree that there's viral RNA, but it may not be live. The concern is if that viral RNA is live and the virus is replicating in the background of an immunized individual, it's going to be selecting, that's going to be selecting for viral variants that can partially evade the immune system and spread, which is not going to be great.
So that has led to a misconception that we shouldn't vaccinate because the vaccinated people are causing additional mutations. But that's not the case. And there's good data now coming out to show that, because vaccinated people are clearing the infection even quicker. A lot of the RNA and virus in the upper respiratory tract is bound by antibodies and is neutralized and can't be given off to other people. So we still need to continue to vaccinate.
So and regarding the emergence of these variants, I mean, a question I get a lot, sorry, I'm just gonna, since we're on this topic, is, are we gonna learn the Greek alphabet by the end of this pandemic? Unfortunately, we're probably gonna learn a few more letters, is my guess. But my suspicion is that viruses, they're not magic. They don't have infinite number of tricks. They're gonna run out of evolutionary pathways to continue to evolve. So this isn't gonna go on forever. And also, we're gonna all eventually get through either multiple rounds of vaccination or some sort of mild, hopefully, infection. And we're all going to get immunity one way or another. So this will recede into some sort of seasonal circulating virus, kind of like flu-like viruses do, other respiratory viruses, RSV, and so on. There's just too many. There's going to be an endemic circulating SARS-CoV-2 population moving forward.
So you're already getting to some of the Endgame comments, and I'm going to come back to that in a minute. But I do want to ask you, one of the common reasons people give for not getting vaccinated is, oh, I've already had it, I don't need it. And I know that you two addressed this at our March event, but I want to come back to that and knowing perhaps more than then, what is your view on the importance, the relative importance of still getting vaccinated, even if you have already had an infection?
I think it's critically important to get vaccinated, even if you've been infected. Because
Jason, I just wanted you to say that for everybody.
Yeah, okay.
Now I want you to justify it.
Yeah. People respond differently to the infections, right? Because for an infection, you have the entire range from an asymptomatic to a severely hospitalized patient. And so the immune responses that we can quantify, we can measure, the neutralizing antibody titers vary by 2 or 3 orders of magnitude, from tens to thousands. And so people, they've been infected, but we have no idea where they're at on this scale. It's a log scale, but it's shown that when you boost, even just with one injection, it really sends everybody's antibody titers up really quite highly. So just getting one vaccination, one shot, if you're previously infected, can really help get you to a very high protective level of antibodies.
Yeah, think of the initial infection as the first shot, and you wouldn't want to go out with one shot of an mRNA vaccine at this point, right? And so you really need another shot, and 2 more shots really give you super immunity that is beyond those who have had 2 mRNA shots, immunity beyond those that have had a natural infection. It gives you superhuman immunity. I just want to stress that. It won't protect you from everything, but it will be higher than anything else you can do.
And even that will still degrade over time, correct?
That's how our immune system works. Otherwise, we would die. Like our blood would be a gel of antibodies from all prior infections, right? We're supposed to recognize a foreign invader, elicit an antibody response, and then let it slowly wane down. So that way there's room for other cells and antibodies to recognize the next infection. So it's a feature of our immune system that's evolved. We can't be ramped up at maximum protective levels against all possible pathogens.
All right. I want to remind everybody it's about 1:45. We are going to take some questions that have been submitted to the COVID questions channel in our Slack workspace. So I see a few people have submitted them to general, but if you don't mind, please put them in COVID questions. We had some instructions. We're not going to put them back on screen, but add the COVID questions channel in the Slack workspace, because Heather is monitoring that channel and only that channel for questions during this. So please submit questions there. And I have a few more, and then we're going to ask some questions from the audience as well. So let's talk about what to do next. We all agree everybody should get vaxxed. We agree they're safe, they're effective, they prevent bad outcomes. The science bears all of this out. And yet people are not not all people are getting vaxxed. Now, I think I read that the vaccination rates have started to go up again in the presence of Delta, and that's good. But what are you guys hearing about reasons people are not getting vaxxed? Are there other reasons that we haven't covered here tonight that you're hearing that is causing people to have this hesitancy or lack of confidence or concern in the vaccines?
Go ahead, Ilya.
Yeah, I was surprised in some folks in my social circles who viewed the virus as natural and the vaccine as man-made. And in those circles, natural things are always preferred, organic, natural, of this earth, and man-made things are synthetic, unnatural, a product of industry, and therefore not as clean for their bodies. Remember, it's just these vaccines just stimulate your own body to do its natural thing. They just do it better because the immune system is focused on a single target that won't send you to a ventilator. And so that's natural. The ventilator is very unnatural.
Jason, are you hearing any other reasons? Ilya, I hadn't heard that one, so appreciate you sharing that one.
Oh, there's a lot of reasons. So
We
many
don't have to get into politics and things, but there is a lot of misinformation, right?
Yes, exactly. A lot of misinformation, and it's hard to combat it all. But the science is really clear on this, and I think it's tough. I think a lot of people want to do their own research, but they're just you might be able to like research a phone or something like that, but to actually sift through primary literature and preprints is really difficult for people without PhDs in that specific field. I mean, it's tough, and people want to do their own research, and they just get misled by Facebook and other things. And every study has caveats and things that like only the experts really know how to properly interpret that. So I think some of the best ways is trying to follow known experts like on Twitter or something to try and get some additional early insight. But the data for all of these are, these are really safe, effective vaccines.
Yeah, one of the things that we want to tackle in the Austin Forum going forward is how to teach people to find trusted information sources and what they can expect from those sources, and to understand that, probabilities are that they're not certainties, and that data collection takes time, and that we may see changes in scientific recommendations. And that's not scientists lying to you 1 month and then telling you the truth 6 months later. That's science learning more, and sometimes reversing a scientific opinion it had, more often refining a scientific opinion. But that's been the biggest one that I've seen, is people saying, well, first they said wear a mask, then they said don't wear a mask, or first they said X and then Y. And, sometimes it's a subtle evolution of an opinion, not actually a change. Occasionally it's a change, but we want people to understand that it's about learning more. The science is objective. It just doesn't know everything from the get-go. Sometimes it takes time and accumulation of data and lots of great brains working on the problem. And we'd like to try to solve that in the Austin Forum. One of the ways is by bringing you guys back regularly and updating us on things like this. But is there more we can do? And is there more all of the attendees can do for themselves and for their friends to guide them to what you can trust, what resources you can trust, how you can, understand you can't watch CNN or Fox about Elon Musk space flights and learn how to build a rocket from that. There's things you can get from news and things you should not believe that as much as an expert about just because you saw it in the news. What can we do in that regard?
First of all, regarding the Musk thing, making these mRNA vaccines in less than a year is really akin to a moonshot. I just want to be clear. Just because we're working with really small things that need microscopes and clear fluids and so on, instead of big rockets and other large equipment that shoots fire, doesn't mean it's not amazing. It is really a moonshot they were able to accomplish in such a short time. Both the companies and industry and academia together. Probably more people working on it in a more distributed way than the Musk rocket, but not, and sometimes that makes it invisible. But in terms of the misinformation, one of the most effective things I was able to do, and maybe this can be translated to other social circles, it's probably one of the most useful things I've done for the pandemic, was to actually dedicate a few weeks to my undergraduates. My undergraduate courses, the undergraduates are educated, they know something about biology, and to give them about 2 weeks on the biology of this pandemic, the biology of the vaccines, and to provide for them a little kit of information that they could spread to their social circles, because misinformation is another virus that's spreading now. And I think there's no inoculation against that. You can only spread information. And so,
Yeah, I think it's difficult. I think our data changes in science. You know, in math, things don't. Like, there's actual proofs, and once it's proven, it's proven. But in science, we actually can never prove something. It can only be disproven. And so we're constantly reformulating and evaluating hypotheses as data comes in. And that should be something people want with leaders. Like, we shouldn't want somebody that makes a decision in the beginning and sticks to it in the face of all this new data accumulating. So we do want people to change. Science is messy. You're seeing it. You know, even when I'm reading the literature, I never hold up one paper as saying, look, this shows something. It's one piece of data that needs to be corroborated multiple independent times by other groups. In some ways, a lot of people think, well, it's peer reviewed. You know, they can find one paper that's peer reviewed that fits, but there's a lot of shitty journals out there. Peer review is just two people usually reviewing it. That could be friends of the authors or something. I mean, it depends. So peer review is not some like gold standard that means everything in this is true. It means it got by 2 or 3 people. And then there could be 10 papers that follow up and show that everything about that's false. That happens a lot. Maybe the original paper needs to be retracted, but hopefully, you know, we're able to figure out like, what are the journals we trust? Who are the researchers we trust? And if you see 4 or 5 papers all roughly saying the same thing, that's when we have confidence. And so that might be different than the other types of research people do where you get like a 1-star rating or something. It's really different.
we're veering off topic here, but the fundamental rot that's happening is the lack of a shared reality. When a country no longer shares the same reality, the same set of truths, things like this happen, right? And that's what's happening. And I'm not sure how to heal the lack of a shared reality, but that's where we are right now. This is just one manifestation of it. That's beyond my pay grade. Sorry, Jay.
No, that's fine. So let's get to one example of that. I've asked you questions mostly about the virus and the variants and the vaccines, but there is one simple piece of technology that I believe substantial data has proven its effectiveness, and that's a mask. And yet we still see resistance to masks. I'm not asking you for your policy statements, unless you want to give them, but I'm asking you to talk about, can you share the scientific expertise and opinions and data related to masks?
It's all you, Jason.
Yeah, so again, as a scientist, it's important to say when you're not an expert in something, and I'm not an expert in the science behind the masks. We know the data are good, that they work, and we've seen it in many of the countries that were able to suppress infections, many of the Southeast Asian countries that mask wearing is just part of the culture that they worked. And there was some maybe mixed messaging early on saying you shouldn't wear masks. That's because we didn't have enough masks even for healthcare workers. And so we didn't want to have a run on masks. But I think it's really clear, the data, that the masks work. You know, a KN95 or an N95 blocks 95% of particles. Again, I think a lot of the population is used to binary outcomes. It works or it doesn't work, and aren't used to things like 95% efficacy. So yeah, I don't want to get too much into the different masks. It seems fit is also very important. You can have a fantastic mask, but if you have seams and you're breathing in the particles through those seams, it's not actually acting as a filter. So both the construction of the mask and the fit of the mask are really important. But it's clear it can trap viral particles. And that's an important point when we think about the inoculum. Like, when somebody is infected, they are infected with a certain number of viral particles. And the more particles you're infected with, generally, the worse your outcome, because you're seeding 1,000 cells or 100,000 cells. When we dose animals for animal studies, we have to choose the number of particles we inject into the animal to cause a SARS-CoV-2 disease, it's usually on the order of 10 to the fifth, 10 to the sixth, right? So 1 million particles per microliter, per milliliter. So it's a lot of particles. And so if a mask reduces the number of particles you breathe in by a factor of 100, that gives your body more of a chance. So again, it's not binary, it's more probability based. And that's why I think a lot, when we're seeing a lot of young people, we're seeing a lot of relatively young, healthy healthcare workers being hospitalized and dying, because you have to imagine that they're in an environment where they're treating highly ill patients in the hospital, exhaling tons of particles. And so those healthcare workers, doctors and others, were just consuming large amounts of virus. That's why we think being outside is better. It's just more chance for the particles to float away. You're breathing in fewer particles.
Jason, you hit on two really important parts there. One, I don't think we emphasize the importance of an understanding of probability and statistics enough in our education. I remember when I was going through undergraduate, calculus was required, but probability and statistics was an elective for most of my friends. If you were in sciences, you took it, but most of my friends who weren't in sciences or engineering, they took the bare minimum math requirement, and it usually wasn't the one that they probably need to understand the most in this data-driven era where we see probability and statistics in news articles and in publications all of the time. So
Yeah,
wish people understood that things aren't binary. They're often on a statistical.
Yeah, right. So there's actually kind of a big push on science Twitter about whether we should replace calculus with statistics, and it might do people good, right? A lot of times for vaccine hesitancy, you hear these anecdotal stories where I know of one person who did X.
Yeah.
But if it's 95%, there's 5% chance, right? And if something's 95% effective and there's 100,000 people, that's still 5,000 people the vaccine didn't work for. And it's not that it's bad, it's just that's probability.
Right. And I really like the other point you emphasized, which these probabilities are calculated, in these large scale occurrence, populations and stuff. But at the individual level, it might very well be about how many viral particles you inhale. And so 10 different people can be in a room and one gets sicker than all the others, but that person may have inhaled far more than the others because of airflow in the room, proximity to the person who was actually sick, et cetera. So
then you layer on the other things, genetic differences, comorbidities, other things. That's why nothing is 100%.
Right. Well, I'm going to ask you one last question and then let Heather ask some from our attendees. And so my last question is kind of like my first. I asked you at the beginning, what's the current status? Where are we now, 6 months or so after you first presented to the Austin Forum? I want to ask you about the end game. What do you think the end game looks like now? And I realize you can't possibly predict the nature of all future variants and things, but your best scientific opinions as to, based on vaccination rates in this country, propagation of the Delta variant, and how it's going to get so many of the unvaxxed people. What are you looking at in terms of weeks to months to maybe even a year before things settle down into what Ilya referred to earlier in this as a seasonal endemic illness?
So yeah, so it's almost a certainty that SARS-CoV-2 is now the 5th endemic coronavirus that will circulate naturally. I mean, there's even possibly animal reservoirs now. We're seeing different, like deer and other, that seem to have high percentages of coronavirus. So it's certainly here. Likely everybody will be infected with it. Even vaccinated people at some point when titers wane and other things, or new variants. So we'll likely all be vaccinated. We'll likely all be infected. We'll have to see what the virus does in terms of its evolution. Like it's experiencing all these people and replicating, making all these progeny. These are complicated viruses. They have close to 30 genes. We focus on changes in the spike protein. A lot of these variants have changes in other genes, other open reading frames that we're actually not quite sure what they do. So there's still probably a lot of play for the virus to adapt. But we don't know whether it's going to become more serious or less serious. But we do know the human population is going to be better prepared because we'll all either be vaccinated or infected. So we'll at least all have some pre-existing immunity in the future. And then hopefully everybody gets vaccinated, but that's almost certainly not going to happen. You'd like to think that everybody who wants a vaccine will have access to a vaccine globally by 2023, I think would be realistic.
Yeah, I wanna add to that. So it's definitely going to go endemic. We have a huge animal reservoir. I don't know if you saw that Europe actually called all their civets and ferrets because there was massive transmission back and forth between humans and civets, and the virus has potential to mutate. It can infect other animals that we live with. I think we are all going to earn immunity one way or another, or at least partial immunity. That's going to happen by either vaccination or not. I think boosters are going to be inevitable for most of us, starting with the immunocompromised and the older folks. I think I'm not going on a limb to say that Delta isn't the last variant we'll be talking about, and future variants will start to have some partial immune evasiveness. That's inevitable because the number of people that are vaccinated or have natural immunity is going to rise, and the virus is going to have to adapt to a different landscape, and the virus will adapt. So is it going to be seasonal like the flu? Can it be coupled with the flu? I've heard talk about that. There's a lot of active work on making pan-coronavirus vaccines. Scientifically, that's possible. There will be things in trials soon to try to do that. How effective those are going to be is not clear. And finally, in addition to vaccines, we have therapeutics, and there's a massive push to continue developing therapeutics. Antibodies are probably the best therapeutics right now if you are sick. There will be small molecule therapeutics that will be more effective than the current ones we have right now. So protease inhibitors, others that are coming out. So that's going to also be improving our outcomes. And finally, I want to mention the roles. Immunocompromised people have not enjoyed the same protections as the rest of us when it comes to vaccination. Immunocompromised people also seem to be some of the sources for much of the viral variants that are coming out. And so we really need to think about how to protect the immunocompromised, because they are both more susceptible even though they get vaccinated. They definitely should be in line for the third shot. And also because they may be a source of variants, because the virus can circulate within an individual for months if they're immunocompromised, and that gives time for the virus to adapt to their immune systems and possibly escape into the wild. So these are the kinds of things that I'm worried about. And also, will Delta pick up some of Beta's tricks?
But on an optimistic note, we know how to make the vaccines. We can reformulate them quickly. So I think we're in good shape, but we sort of always figured we would need some sort of periodic vaccination and reformulation of the vaccine, just trying to figure out the timing, whether it was yearly boosters, biannual, when do we switch to make a variant? And that could also be, it might not be the same for all age groups. Higher risk groups could have a different dosing schedule than younger groups, for instance.
And it's possible different countries will have different variants that become locally, because there's founder effects and so on. So local, different, as we remember the South African variant, the Indian variant, right? So they circulate in certain communities. So different boosters may be appropriate for different regions. I think at the end of the day, if we can reduce COVID from a life-threatening disease for those who have never experienced it before to maybe a mild cold, that's the end game I envision, and I hope we get to. For most folks, if COVID becomes a mild cold, that there's the COVID season again, let's shake it off. That's the end game I hope we get to pretty soon.
Well, it's not a perfect end game, but it's certainly a pretty good one, all things considered. So thank you for sharing that. I think most of the people in my circles sort of expected to hear you guys say that was the likely end game. And I hope we get there soon. And I hope we can have these Austin Forum events in person again soon. I'd scanned through the chat here really quickly. Saw lots of nice comments. I see that we have to post the Slack instructions many more times than we do, but we'll get everybody on board with Slack. Some people have asked questions in the Slack channel. However, I do want to go to those. I did see that somebody posted a question at the end of the chat. What is Jay's favorite whiskey on that shelf behind him to the right? As sort of a little present to myself at the beginning of the pandemic, Jason and Ilya, when everybody was saying the hand sanitizers had to be 60% alcohol, I decided that my whiskey should be 60%. So I got Barrel Dovetail, which is 62%. I know it probably didn't have any possible impact, effect on the insides, but it sure did help me get through the pandemic. So Tracy, that was my pandemic whiskey of choice during the last several months.
Do you have Blanton's bourbon in the background there?
I do. Wow, good eye. I do.
It's a good one.
Yeah, there's a lot of good ones on that bar. So, and I look forward to us meeting again in person, because those who have been to events before in person know that we treat everybody, thanks to our generous sponsors at Trifecta, a neighborhood bar that happens to have a great whiskey selection that they've actually asked me to help curate. So hopefully we can do that again soon. Heather, we're not going to have time to promote people live to get through these. So this is the rapid fire round. And Heather is going to start asking you 2 questions from the COVID questions Slack channel.
All right. And Ilya and I will try and keep answers to less than 30 seconds so we can get through a bunch.
So this is the first one, and this is on, I know, on a lot of people's minds as school is starting. This question is from James Beams. Is there anywhere data is available that shows the trend of infections per deaths per age group over time? I've seen data. All the data I've seen is an aggregate per age group since the beginning. I'm asking because I hear this variant is worse for younger age groups, but it's hard to find public data to reinforce this. I'm wondering what will happen with unvaccinated kids under 12 as schools open up.
Yeah, good question. I think there is concern for the pediatric population, and you're seeing a lot of pediatric ICUs filling up. So at least anecdotally, qualitatively, it does appear to be worse than, but we didn't see that during like the first, second, third waves. So the Delta variant does seem to be worse for the younger population. It's true on a lot of the different age stratified stats I've seen. They'll group 0 to 17 years of age, and that's not helpful. So I haven't seen the type of resolution, but if I find it, I'd be happy to try and post it somewhere.
Okay, thank you so much.
I have 2 little kids. I've been looking. I haven't found. The other confounder is Delta is new, and a lot of the data is time averaged over all the variants. This is a major problem. So it's not stratified enough in age and not enough in time.
Yeah. So even 3 months worth of data might only be really the last month where it was mostly Delta, and so it's a dilution.
Okay.
So there's an epidemiology group here at UT Austin that models these things. They just put out a model for school transmissions in the Texas area, in the Austin area specifically. And that should include Delta implicitly because they're looking at transmission in the population, which is already 100% Delta. And I wish I had good news for you. But in short, we're going to be hearing a lot about closures and outbreaks in schools immediately.
But if an infected person has a mask and they breathe out particles and that mask traps 95%, and the other person who breathes in has a mask and blocks out another 95%, that's how you reduce the number of infectious units you're breathing in by 2 or 3 orders of magnitude. And so you might still get sick, but your outcome will be a lot better.
Okay.
I'm outfitting my kids with high quality masks and, getting to work in the lab. That's all I can do.
Okay. A follow-up question is, what about the new Lambda variant?
Lambda's been around for a while, actually.
Okay.
I don't know. It's okay. It's not as worrisome to me as the Delta variant. It doesn't have much in the way of immune escape. Has an L452R substitution in the RBD, but yeah, it doesn't seem to have taken off the way Delta has.
It's been largely suppressed by Delta in the Texas population. I have hard data on this.
Yeah.
Okay.
But
It's lost.
we're seeing some stratification now. Delta's being broken down to Delta A, Delta B, and apparently Delta D is what's starting to take over now and is now like 90%. So we are starting to see some of the sub variants of Delta forming and taking hold.
I want to make sure that I understand what you mean by suppressed, Ilya. You mean that a different variant that spreads it's more contagious and spreads to more people, creates antibodies that make them less likely to get the other variant. Is that right?
No, the variants are competing against each other where you are the host. So as they spread through the population.
Host 2 at the same time?
Yeah, think about it as 2 race cars. They're racing in a track. One pulls up ahead of the other. That's what's happening. So Delta is spreading more rapidly, and there's just fewer people to infect for the other variants.
But Jay, I would say that you're right in the sense that like you're competing for naive or infectable individuals, right. And so if that one person gets infected first with Delta, that does then kind of block Lambda from replicating in that person in the near term.
Okay.
And we
Right.
do have a request for clarification. This is from Kendall Baker. From my understanding, those who receive the J&J vaccine should go to get an mRNA vaccine. And are the booster shots the same as the original mRNA vaccines?
Yeah, with the caveat that I'm not a doctor and should not give medical advice. If I received J&J one shot, I would strongly want to obtain at least one and probably two doses of an mRNA vaccine. The mRNA vaccines have not changed yet, so it's still 100 micrograms per dose for the Moderna, 30 micrograms per dose for Pfizer.
I concur, and I have already texted my family members that got J&J for expediency or other reasons to go get an RNA vaccine, a full RNA vaccine. I'm not a medical doctor.
Okay. Okay, let's see here. Let's see here.
These questions are really important and good. Jason and Ilya, do you mind if we go a little bit beyond 8:15? I'd like to get more of these questions in.
Yeah, I can go to 8:30.
We'll stop at 8:25 and Heather and I will do final slides at 8:25.
So here's a question from Liz. Is there a question about the antibody infusions that are being administered? We have some family who have had COVID and were not vaccinated and preferred or welcomed this instead of the vaccine.
I would not recommend that.
Yeah, it's more of a last ditch effort with a narrow time window for effectiveness.
You got to use them real quick, like right when you get infected. And for some people, they work. They are not without side effects, and they require sitting there with an infusion, like intravenous infusion.
Yeah,
you're doing this in a hospital setting. This is not easy. This is not a first thing, a first response I'd go to.
Yeah. You generally have about 48 hours post-infection to receive the antibodies for them to have any benefit. Once you're severely ill and going to the hospital, it's too late. By that point, it's your own body's immune system doing most of the damage. And so adding 8 grams of additional antibody isn't going to help.
Yeah, and the reason for that is the virus, the viral particles just replicate so quickly that adding a few more grams of antibodies to your blood, which is actually quite a high dose,
I was just going by Trump's regimen, which is 8 grams.
That's a really big dose. Of course, we don't know his real weight, so we don't know the mgs per kg or whatever. But anyways,
okay.
The bottom line is, let's not go there if you don't have to.
Okay. And this, you may have addressed this, but this is a request, I guess, to go a little bit more deeply into this. This is from Nancy Lyon. We hear a lot about the immunocompromised, but where do people with autoimmune diseases fall on the spectrum of protection from vaccines?
I'm not a doctor, and that's beyond my pay grade.
Okay.
Yeah, this is another. I don't have the expertise.
Okay.
It's not. I don't even know what's being recommended in terms of whether people should be vaccinated who do have autoimmunity or not.
Okay, that's fair. All right. Let's see. Question, what are your recommendations specifically for people with infants?
They're good years and enjoy them.
That's true.
But yeah, I don't know. That's a pretty wide open question.
That is. It's not very specific.
It's hard to recommend anything other than to just stay protected and continue to wear masks, even if you're vaccinated, reduce the number of people around said infant, and so on.
Okay. This is from Scott Collins. What is the bottleneck in deploying vaccines to most of the world's population other than the cost beyond cold chain logistics? Is it production? And how do we solve this?
Production is a huge global problem. There's manufacturing that happens across 3 different continents to produce a single vial of these vaccines. There's the lipids, there's the RNA, there's the bottling, there's the quality control. Freeing the intellectual property is just silly because these are hyper-specialized instruments. In fact, I believe the instruments that package the RNA into the lipid nanoparticles are actually quite limited, and they're highly specialized. And I'm sure the world's capacity towards making such instruments is already fully engaged in producing more of them. But it's a huge logistical supply chain to just make a vial.
Yeah, I don't think cost is actually that limiting at the moment. It's just the mRNA companies are trying to make 1 billion doses by the end of this year, but that's so it only protects 500 million people, and we have 6-7 billion people in the world. And then there's spoilage and other things, right? You hear about certain counties or states throwing out thousands of doses because they've opened the
Heartbreaking.
vial, but then
Yeah.
so there's but then also cold chain and others. So
But the cold chain has not been a major challenge, at least for most of the regions we've delivered them to. That may be self-fulfilling. As that vaccine becomes more available globally, cold chain may be a problem. Hasn't been a major problem yet because there's just not enough vaccines to send to places where the cold chain is limited.
I'd say we were also hoping that maybe by now there would have been more vaccines that had received emergency use authorization. We only have 3 in the US, 4 to 5 or 6 globally. I thought maybe there'd be more by now. And there's also the issue that as soon as Pfizer or Moderna actually gets approval rather than emergency use authorization, it'll make it impossible for another vaccine in the US to receive emergency use authorization. So there's some interesting policy at play too.
Yeah. We also don't have a very clear understanding of the correlates of protection, which gets back to the question of boosters and how we tweak the formulations. So you don't want to run a phase 3 trial or even any kind of trial. You want to just basically correlate protection to vaccine formulation, and we don't quite have that yet. Although I would imagine that would have been done by now.
Papers are coming out now showing its antibodies.
Yeah, I figured, but we just need to have that for policy decisions to be able to tweak these things quickly and to produce new ones.
Right. This question is from Jamie Gill. And I believe you touched on this somewhat, but maybe you can talk a little bit more about this. 5 years from now, when the majority of the world's population has been infected or vaccinated, how do you predict SARS COVID-2 will behave as an endemic coronavirus?
It's hard to say.
Right.
5 years. 5 years is a long time.
If I
for
could
virus.
predict 5 years, I'd be investing in the stock market.
Okay.
It's really tough because it's going to depend on what the virus does, and we've already seen in 18 months it changed a lot to get the Delta variant. So it's hard to say. It's possible that in vaccinated healthy adults, it causes a mild infection. It could still cause severe cases, maybe in elderly, immunocompromised, high risk. That would be similar to flu.
Okay. Let's see here.
And just to mention how unpredictable this is, there are some vaccines you take, and that is a one and done thing, right? You may get a booster eventually, only if you're going to a high risk area. And some vaccines you have to do seasonally, like the flu. So really, we don't know. I told Jay we would be celebrating in person by this time, and I was almost right. We had 2 glorious months, but I was completely wrong in the end.
I looked for you at that June event at Trifecta. I didn't see you.
And I was completely wrong. So therefore, I will not predict anymore.
And then this is something again that we have some people who joined later and some people have come and gone and whatnot. And this was an earlier on question. Can you explain the difference between the protection provided from vaccines versus the protection provided through naturally acquired immunity? And then how do these variants affect this?
At a molecular level, the protection is quite similar, but the degree of protection is substantially increased with vaccines. That's the short of it.
Okay.
Yeah, there's some other differences. For a vaccine, most of the vaccines, you're just generating immunity against the spike protein. When you're infected, you are generating immunity against other proteins, different T cell epitopes. But the protection due to infection is extremely heterogeneous and varies a lot from person to person and is not always robust, whereas the vaccines in general are producing a very similar, robust response in all the people that receive it.
All right. And then to sort of bring it all together, and this question has been asked in 1 or 2 versions. What, if any, comparison can be made to other prior viruses in past history? And we received a similar question comparing this to the Spanish flu. Do you predict it lasting, the same amount of time? Basically a request to compare what's happening now versus what happened then.
Jason, it's all you. I'm not a historian.
It's hard to compare it to something. Spanish flus is reasonable. There are a lot of differences between coronaviruses and influenza viruses. Influenza viruses have segmented genomes, so their genomes have 8 different parts. They can reassort and recombine if a host is infected by 2. Coronaviruses can't do that. We're seeing this more general evolution of SARS-CoV-2. Influenza viruses undergo antigenic drift and antigenic shift. Drift is the sort of yearly accumulation of changes. Antigenic shift is usually due to a reassortment. That's often when we have a new pandemic, a swine flu or something, where it's just so different. Our pre-existing immunity doesn't recognize that. So I think coronaviruses will be doing more of this antigenic drift, slowly making changes over time. But it's hard to say. It would be a lot different if everybody was getting vaccinated routinely. But without that, there's going to be pockets where the virus can flare up and mutate. And so if all the vaccine hesitancy and misinformation, if this was around 50 years ago, there's a chance we wouldn't have eradicated smallpox. That would still be going. So it's hard to predict now what the virus is doing and what people's behavior will be.
Okay. Thank you very much. And with that, Jay, I think we've concluded the bulk of the questions.
All